Okay, so we're going to come to this idea of reactants in excess. So this follows on from our reacting mass equations. So if we think of this reaction here, which is using the extraction of titanium in it, so how titanium is made industrially. So you get titanium chloride and you react it with sodium, you get displacement reaction, you get titanium metal and sodium chloride. So to balance that, we need to put a 4 there and a 4 there. Now, titanium chloride is very expensive, so you want to make sure that all of it reacts. The sodium is much cheaper, so instead of working out the exact amount by using a reacting mass calculation, instead of using the correct amount of sodium, you add a lot more than you need. And we say there that the sodium is in excess. Well, the opposite way of saying that is to say that titanium chloride is the limiting reagent. Okay, now this is pretty important because you nearly always have one of the reactants in excess. You don't usually work out the exact right amount. If you think of all the experiments that you do in the lab at school, if you put like calcium carbonate into acid, you usually add enough acid, more than enough acid, so that all of the calcium carbonate reacts. Or you put magnesium into acid, you work out that there's enough acid to dissolve all of the magnesium. So it's something that you do all the time. So anyway, here's a typical exam question, which I've got down here. Okay, so I'll rub that out. Right, so here we have got titanium chloride with sodium, same reaction before. It says we've got 40 grams of titanium chloride, that should say. We're reacted with 30 grams of sodium. And you've got to show that the sodium is present in excess, or we could also say that, in other words, titanium chloride is the limiting reagent. It's the opposite way of saying it. The reactant or reagent, doesn't really matter. Okay, so how do we do this? Right, so we need to work out the number of moles of titanium. And we know that for every 1 mole of titanium, we are going to need 4 moles, 1 mole of titanium chloride, sorry, we're going to need 4 moles of sodium. So moles titanium chloride is equal to mass over mR. Right, the mR of titanium chloride, well, titanium is 48 and chlorine is 35.5, so 4 times 4, 35.5. The mR of that is 190. Okay, so that's equal to we've got 40 grams over 190. That is equal to 0.2105 moles. Okay, so now we know how many. So if 1 mole of titanium chloride needs 4 moles of sodium, there, so 0.2105 moles are going to need 4 times that, which is 0.842 moles of sodium. Right, let's work out the mass of that much sodium then. So rearrange our equation. We get mass, what is the mass of sodium we need? Mass is equal to the moles times by the mR, the AR really, because it's sodium, the atom. Atomic mass, relative atomic mass. So the moles is 0.842. And the atomic mass of sodium is 23. So that is equal to 19.4 grams. Okay, so 19.4 grams of sodium are needed. That's the minimum amount. But look how much they use. Well, it says here they have added 30 grams. So you can see there's a large excess of sodium there. And that should ensure that all of the expensive reagent, the titanium chloride, reacts. And you don't mind if you've got a bit of sodium left over at the end. Okay, so we'll do another example. Right, so basically it's the same calculation as a reacting mass calculation, but just this new idea of having things in excess. Okay, so here's another reaction. This time we are reacting ethene. If you've done organic chemistry, you'll know the structure of ethene to be that. It's got a double bond in it. And you add water to it and you make ethanol. Not surprisingly, the ethene, that is expensive because water is pretty cheap. So you're going to want to make sure you're adding excess water. So the question here, it says 65 grams of ethene react with 80 grams of water. Shows that it should say the water is in excess there. I've written that wrong. Water's in excess. Okay, so what we're going to do again is, well, this is quite an easy ratio here because we know that 1 mole of ethene is going to react with 1 mole of water. Okay, so let's work out our moles of ethene. So moles of C2H4 is equal to the mass over the MR. The mass we have got is 65 grams. And the MR of ethene, so it's 2 times 12 for carbon, plus 4 for the hydrogens, that's 28. So 65 divided by 28. 2.32 moles of ethene. So we can say then, well, if you've got 2.32 moles of ethene, we're going to need 2.32 moles of water. Okay, so mass of the water then, so we have to do our rearrangement. Mass is equal to moles times MR. The moles 2.32, and of course the MR of water is 18. Probably remember that one. And that is equal to 41.7 grams. And how much water are we actually adding? Well, we're adding 80 grams of water. So you've got a large excess of water, or the limiting reagent, limiting reactant is ethene. Okay. So that's how you do that. It's basically the same as a reacting mass calculation. Just if you want to do them yourself later on, here's a couple of examples. Okay, so with the answers there. So the first one is, here we go, reacting sodium with chlorine. 13 grams of sodium and 30 grams of chlorine. You've got to show that the chlorine is in excess. By the way, the answer is you only need 20.1 grams. So work that out. Yeah, that will prove that you've got the right answer. The next one is aluminium reacting with chlorine, and here we've got 25 grams of aluminium reacting with 120 of chlorine. And you've got to show again the chlorine's in excess. And this time, if you work it out, you should find that the minimum amount of chlorine that you need is about 98.6 grams. Okay, that's the end of that video.